Hi everyone. This video is intended to show the setup and running of a conduction of heat investigation. There are three ways in which heat can flow: conduction, convection, and radiation. This experiment is intended to demonstrate and investigate heat transfer via conduction. There are two parts to this experiment. Part 1 of the experiment is a demonstration in which we will use paper clips to observe heat conducting through a metal rod. Part 2 of the experiment is an investigation in which we ask the question, do all metals conduct heat equally, or do some metals conduct heat faster than others? To begin with, we need to prepare our materials. In both parts of the investigation, we're going to need paper clips cut in half that we're going to stick to metal rods. Once the paper clips are cut in half, we will drape them across the metal rods and stick them to the metal rods with melted wax. In this image, we see the setup for part 1. A metal rod is suspended horizontally across the workbench. Paper clips have been cut in half and are attached to the rod with wax. We initially draped them across the rod, dripped the wax onto them, and then turned the rod through 180 degrees so the paper clips pointed up. In this part of the investigation, we intend to apply heat to the left end of the rod and observe the time it takes for the paper clips to fall. In the footage you're seeing here, I set the paper clips at 2 centimeter intervals. Even at 2 centimeter intervals, when I applied the Bunsen burner to the left-hand side of the rod, it took 2.5 minutes for all the paper clips to fall. When I originally ran the experiment, I set the paper clips at 5 centimeter intervals. I found that the last 2 paper clips at 20 centimeters and 25 centimeters simply didn't fall in any reasonable amount of time. At 2 centimeter intervals, the paper clips fell at 9 seconds, 28 seconds, 56 seconds, 1 minute and 38 seconds, that's 98 seconds, and 2 minutes and 38 seconds. That's 153 seconds. Just to speed up the process, I've increased the speed on the footage here, and we'll see the last 3 paper clips falling. The data collected should naturally be recorded in a table. In this investigation so far, for part 1, the independent variable was the distance from the heated end of the rod, while the dependent variable, the variable that we measured, was the time taken for the paper clips to fall. Part 2 of the investigation looks at whether or not metals conduct heat equally, or if some metals conduct heat faster than others. In this part of the investigation, we're going to use a conductometer. The conductometer pictured here has 3 spokes. There's a copper spoke, a brass spoke, and an aluminium spoke. We will affix our paper clips to the ends of each of these 3 spokes. We'll apply heat to the hub, and we'll take note of which paper clips fall first, or if they all fall at the same time. This way we'll get an indication of how quickly heat passes through each of the 3 different metals. Once again, we're going to need to cut our paper clips in half. You'll notice when you cut them in half that one end or one half has a slightly bigger bend. This is the bend we want to drape across our metal rods. We'll apply wax to the paper clips to make sure that they're fixed firmly to each of our metal rods. We've got copper, brass, and aluminium. When we're satisfied that we've added enough wax and we're satisfied the wax is dried, we will carefully rotate the conductometer around 180 degrees so that when the heat reaches the end of each spoke, the wax will melt and the paperclip will fall. After lighting the Bunsen, direct the blue flame at the hub of the conductometer. If all metals conduct heat equally, then we should see all the paper clips fall at exactly the same time. If not, we'll see them fall one after the other. We will record the time it takes for the paper clips to fall. In this part of the experiment then, our independent variable is the type of metal in the spoke, whether it be copper, brass, or aluminium. Our dependent variable is the time it takes for the paper clip to fall. The independent variable is the variable we manipulate. By using a conductometer, we manipulate the types of metals that are available for the heat to pass through. So the types of metal is the independent variable. We measure the time that it takes for the paper clips to fall. So the time is the dependent variable, the variable that we measure. This brings us to the end of a video showing how to set up and run a conduction investigation. After you've conducted the investigation yourself, you'll need to process the results and write up a lab report. I hope this video was useful.